This video shows web3j-scala, an idiomatic Scala wrapper around web3j, which is itself the Java 8 version of web3.js. These three libraries all leverage the JSON RPC protocol that Ethereum clients like Geth support. web3j is a lightweight, reactive, somewhat type-safe Java and Android library for integrating with nodes on Ethereum blockchains. This library, web3j-scala, provides additional type safety and enhanced scalability over its Java and JavaScript cousins, as well as the pleasure of writing solutions in Scala. Another important feature of all these libraries is their ability to compile Solidity smart contracts. Now, web3j-scala and web3j emit Java code, while web3.js emits JavaScript for Node.js programs. This project promotes the use of idiomatic Scala in the following ways. Variables and no-arg methods are actually names of properties, so set and get prefixes are not used. This means that some properties do not have exactly the same name as their web3j counterpart. In general, zero-argument methods only require parentheses if they perform side effects. Scala data types are used to the maximum extent that makes sense. For example, Scala concurrent future instead of the Java future. A functional programming style is encouraged by always returning immutable data types from methods. For example, instead of getting an array back, this library returns Scala collection immutable list. Like web3j, web3j-scala offers both synchronous and asynchronous APIs. However, web3j-scala uses Scala features instead of Java 8 features, as you might expect. web3j features RX Java extensions, and web3j-scala wraps that syntax in Scala goodness. For example, the web3j-scala observable methods provide simple and efficient application code. Scala's value classes provide additional type safety without any runtime penalty by wrapping the JVM code. web3j-scala does this by providing the following value classes. Implicit conversions are provided that make it easy to obtain instances of the desired value classes without sacrificing type safety. For example, the following code implicitly converts the Java lang string returned by basic info contract send get contract address into an address. This project consists of two sub-projects, one for demo and one for the library itself. To use as a library, simply add the following to your SPT project's build.spt file. To run as a demo, you're going to need an Ethereum client somewhere, which might be local or could be elsewhere. You could use Geth, Parity, or whatever makes sense for you. The run Geth script invokes Geth with a bunch of options that are convenient for development but not secure enough for production. The Ethereum data directory is set to the .ethereum directory in your home, or a subdirectory that depends on the network chosen, which will be created if required. HTTP RPC server is enabled at localhost 8545, and all APIs are allowed. Ethereum's experimental Whisper message facility is enabled. Inter-process communication is via a virtual file called geth.ipc in the .ethereum subdirectory. A web services RPC server at localhost 8546 is enabled, and again, all APIs are allowed. Verbosity level info is specified, and a log file for the Geth output is written or overwritten in logs geth.log. That directory is created if it doesn't already exist. Geth will continuously scroll output so long as it continues to run, so you must run the demo programs in another shell. The demo programs follow the general outline of the web3j Getting Started documentation adapted for this project, including synchronous and asynchronous versions of the available methods. Each demo program starts with a demo context, which performs some setup common to all the demo programs. Demo context also demonstrates how to use web3j-scala's synchronous and asynchronous APIs. The different demo programs are demo observable. web3j's functional reactive nature makes it easy to set up observers that notify subscribers of events taking place on the blockchain. This demo shows how to work with RX Java's observable from Scala. Demo Smart Contracts compiles an example Solidity program that defines a smart contract, creates a JVM wrapper for the smart contract, and exercises the smart contract from Scala. Demo Transaction demonstrates enhanced support beyond what web3j provides for working with Ethereum wallet files and Ethereum client admin commands for sending transactions. This is the help for the demo script that will appear if you do not specify any arguments. There are more scripts provided. The one that's most interesting is the web3j script, which runs the web3j command line console. The script first starts by building a fat jar, so the command will run quickly on subsequent invocations. You can invoke the script without any arguments to see the help message. If you'd like to get involved with this project, we'd love to bring you on.